Hello, I'm Daniel Stolarov. I'm the President and CEO of Graphene 3D Lab. Our company is developing functional nanocomposite materials for 3D printers. FDM printer is a terrific tool. It can print almost any shape you can envision. However, its abilities are limited when you need to print a functional device such as a robot or gadget. And this is because functional device combine in itself many different functional materials such as electric conductors, magnetic materials. And our company developing these kind of materials by combining thermoplastic with nanoparticles. As a result, we get a nanocomposite material which has functional properties such as conductive thermoplastics.
Graphene, a key component in our conductive 3D printing materials, is a single atomic layer of carbon atoms hexagonally arranged, which has several important properties. In fact, it is the most electrically conductive material ever isolated, and also offers superb thermal conductivity and mechanical strength. There are several different forms of graphene, including CVD graphene and graphene nanoplatelets. While CVD graphene is used for transistor and other applications, graphene nanoplatelets are used in the creation of functional composites. When in nanoplatelet form, graphene can be easily mixed with thermoplastics commonly used in FFF 3D printing. This allows us to create a nanocomposite material which, when turned into a 3D printing filament, may be used in standard 3D printers. These filaments possess functional properties, including thermal and electrical conductivity, and are an important component of Graphene 3D's 3D printed battery. Fused filament fabrication 3D printing, or FFF, is the process of using a printhead to heat and simultaneously extrude filaments, or 3D printing inks, layer by layer, creating objects. Filaments with functional properties allow us to print not only inert objects, but their functional components as well. The key to powering any electronic object is to have it attached to a power source, which is why we have developed a battery manufactured entirely using a 3D printer. Our 3D printed battery uses graphene as a key element in the creation of its components and can be printed in virtually any shape, allowing it to be easily integrated into almost any 3D printed device. As you can see here, our 3D printed battery is housed inside of a structure which, when activated by electrolyte, will begin an electrochemical reaction and the battery demonstrates voltage. It is important to note that while our process required the separate printing of individual components, with the development of a true multi-material 3D printer, it will be possible to print this entire object in one single print. Now, as you can see, we are able to clearly demonstrate the voltage of our 3D printed energy source using a multimeter, and the battery functions as it should. In fact, our battery reaches the same voltage as a commercially available AA battery. The final step of any project at Graphene 3D is to extensively test our materials, ensuring that they meet our expectations. At our in-house materials testing laboratory, we are able to confirm a range of important characteristics, including viscosity, tensile strength, the proper diameter size, and more. We are also able to confirm, using our electrochemical testing station, that our battery has the proper parameters and characteristics. The output of our energy source can be guaranteed.
I believe there is a bright future ahead of us. Our products can be used in the multi-billion-dollar industries such as aerospace and robotics and energy storage. And thank you very much for the opportunity to present our company to you. And I am looking forward to sharing with you our future development.